Welcome to an introduction to vector drawing, the foundation of all the cool tools at Makersmiths. The goal of this introduction video is to familiarize you with what vector drawing is, ways you can use vector graphics in your projects at Makersmiths, some of the programs you'll likely use in your projects, what CAD and CAM are, and a rough order of operations that you'll likely use for your laser, vinyl, and CNC projects. Most people think of CNC as sharp router bits spinning very fast and cutting wood or metal. CNC actually stands for Computer Numerically Controlled, which actually applies to a lot more Makersmiths tools like the laser cutter, the vinyl cutter, and the plasma cutter. All of these computer numerically controlled tools actually rely on vector graphics to all or some degree. In addition, additive manufacturing processes like 3D printing also utilize vector graphics, albeit in 3 dimensions. And if you want to do large format printing, such as on the plotters at Makersmiths, vector graphics can be used to ensure that your designs don't pixelate, or in other words, get very blurry when you blow them up and make them huge on the plotter. The good news is that the vector drawing class will help you get familiar with these base skills to use any one of these machines. They are all very similar in that you create a design in a vector drawing program first. You then translate that design into a code that the machine understands, which is frequently but not always G-code, with the attributes that each particular machine needs. The machine then executes those commands, either cutting where and how fast you want it to cut in the case of subtractive manufacturing tools like the big red CNC or the laser cutter, or moving and extruding layers of plastic in additive manufacturing processes such as 3D printing. Either way, a solid foundation in vector drawing and vector graphics will set you up for success in using many of the coolest tools that Makersmiths has to offer. So, let's start with what a vector image is and how it is different than the raster images most people are used to working with on their computers. A raster image is one that's made up of pixels, or tiny squares, of different colors and different transparencies. Every photograph you've ever taken or used is going to have been a raster image. Taking a picture with your cell phone essentially captures your image as thousands or millions of tiny little pixels. When you're editing a photo, no matter what fancy tools are in your editing program, you are basically just changing the color and the transparency of those pixels one by one or by the hundreds, depending on what kind of tool you're using. Vector images, on the other hand, are very different. They're made up of strokes, which you can think of as lines, that can be curved or straight and have a line thickness and or a color. They're made up of objects, which you can think of as shapes that have a fill color and a transparency. Strokes and objects are defined then by nodes. Nodes are basically where the start and the end of a line are and can be used to define the boundaries of a shape. Nodes and the strokes connecting them to form objects are defined by math equations. You don't need to know the math equations, you just need to understand that rather than editing individual tiny pixels by changing their colors and transparencies and drawing on them like you would with the pencil, marker, or paintbrush tool in your particular program, you actually create vector graphics by drawing the lines and shapes, then moving individual nodes, adjusting curves, and applying fill and stroke colors to get the vector graphic you want, no matter how simple or complex that shape may be. To illustrate the point, on screen you have a stylized horse and the 2 versions of what you'd see if you zoomed into the eye of that horse, one in raster and one in vector. If it's a raster format and you zoom in, it will eventually start to blur and you'll be able to see individual pixels. If it is in vector format and you zoom in, the image stays crisp and clear. All photographs are raster images, no matter how high the resolution or how many megapixels the image is made up of. Here, the letter O is shown, zoomed very far into a high-resolution camera image, so it looks like a bunch of individual pixels. As you zoom out, the picture becomes clearer because you can't see the individual pixels any longer. But if you zoom out far enough, because this is such a high-resolution image, you can't even see the O because it's now too small. You may know that the sign says one way because you recognize the shape of the sign, but you can't really actually make out any of the letters. But no matter how high a resolution the image is, or how many thousands or millions of pixels are used, the image is still just made up of tiny squares. And it would be really hard for a machine to find the line to cut on, engrave on, or extrude material to create a smooth letter O from this image made up of little pixels. Even if the image you have on your screen looks like a smooth O, as long as it's a raster image, it really won't work for most CNC-based projects. So I've spent the last 4 minutes explaining why raster images don't work for CNC-based projects because it's the type of image that most people have the most experience with. So let's now talk about vector images and how they work for CNC, laser, plasma, and vinyl cutting projects. As opposed to photographs, vector graphics are typically logos, line art like cartoons, and diagrams that use strokes, objects, and nodes rather than pixels. It's these lines and objects that all of these machines use to create your final product. To illustrate the point, here is a vector logo from an old t-shirt zoomed all the way out so that you can see the entire image. And no matter how far you zoom into that vector image, the lines stay sharp and clearly defined. This is the eye of the turtle, just as clear and crisp zoomed in as it is zoomed out. This doesn't mean that vector graphics have to be boring and limited to line art images in 2 colors. Vector graphics can be used to create very complex drawings for print purposes, though these wouldn't necessarily be suitable for using on a vinyl, CNC, laser, plasma, or 3D printing project. Vector images and graphics that are more suitable for production processes are often made, though, of only 1 or 2 colors comprised of some pretty basic lines and shapes. The top 2 images show a vector image of a swim team logo that we saw before that was cut out on white heat treat vinyl on a vinyl cutter and then heat pressed onto a t-shirt. The bottom 2 images show the layout of a set of jigs that can be cut out on the CNC machine. The bottom project could be done by hand, but it would take far longer, and drilling all of those individual holes exactly the same distance apart would not only be difficult, but also ridiculously time-consuming. Many corporate or team logos are originally vector images, so that they can be made as large as necessary without becoming blurry, such as a high school mascot for a sign. Designs can also be more complex, where it takes multiple steps to cut out multiple pieces, which are then glued together as a finished project. Vector images can also be used in very large print graphics on paper or vinyl that can be used as a stencil on cornhole boards, like on the top image. 3-dimensional projects like a bar top arcade unit are drawn in a 3D CAD program, which are also in vector format. Then the 2-dimensional vector drawing of each piece of the unit can be laid flat and cut out individually on a large format CNC machine. Another vector logo, like the knight chess piece above, can be used to engrave on glass on the laser cutter. A different horse image could be used to carve on a sign to put near your front door. To recap, no matter what your project is, vector images are going to use paths, strokes, and nodes, while raster images are made up of pixels. Vector file formats are different than raster file formats. Some of the programs you could use for vector drawing as a hobbyist, in order of cost from most to least, are Adobe Illustrator, Corel Draw, Inkscape, and Fusion 360, just to name a few. For raster images, you'll use programs like Adobe Photoshop, Microsoft Paint, or GIMP. Vector drawings won't pixelate no matter how far you zoom in, but they don't work for photographs or photorealistic images. Raster images will pixelate as you zoom in or the image size is increased, but are designed for photographs and images that need to look realistic. Next up, we're going to show you how to use vector images in your projects. First off, each type of tool that you draw for may require a slightly different drawing style, but they are all still vector images. And the good thing about vector images is that changing the style to match the tool is usually pretty straightforward. So let's start with the image on screen of a stylized horse and the number 40, which was used to create a sign next to a front door. Each tool usually has different software that actually runs the machine and that you import your vector graphics into. If you load the horse image from the previous slide into the vinyl cutter software, the cutter will cut whatever color vinyl you load in the machine. In other words, the color of your actual graphic doesn't really matter. There are not a lot of settings on a vinyl cutter, so once you load your image in the software and load your vinyl in the machine, you'll usually just hit cut and go. If you load the same image into VCarve, in order to set it up for CNC, it will appear as an outline, but then you need to choose what kind of cut you want, how deep it should be, and what kind of cutter you're going to use. So even with the same base image, there are lots of different ways you can make your project look depending on your settings. And if you have sent the red graphic to the laser cutter software, the software on standard settings would have no idea what to do with it. For a little more detail, vinyl cutter software usually sees both the outline strokes and the fill colors in your imported vector drawings. The original color is shown, but only the strokes really matter because that's where the machine will cut whatever color vinyl you actually loaded into the machine. In VCarve, which many people at Makersmiths use for CNC projects, the software recognizes the stroke or outline of the shapes in your vector drawing and doesn't care what color fill you actually used. And then you set up toolpaths, which are basically what you want to do with each stroke or shape. You might want to remove all material inside a shape, or just cut a groove on the line of a shape. This is an example of CAM, or computer-aided manufacturing, where you're using software to generate the code that tells the CNC machine how fast and where to cut. The ULS program on the laser cutter is a little bit different again. With the laser, the line color and thickness matter because the software interprets different colors as instructions to do different actions with the laser. With the standard settings on our laser, red lines are for cutting all the way through the material, blue lines are for engraving on the line that you drew, and black lines and shapes are for raster engraving. Here is a sign made using the same vector image of a horse from earlier. The order of operations was to first create the image in Inkscape, import it into VCarve, create toolpaths in VCarve, then cut the project out on the big red CNC machine. I've also engraved this on glass using the laser cutter and cut it out of heat treat vinyl and applied it to a t-shirt, all using the same original vector drawing. Three-dimensional projects can be drawn in more complex CAD programs like Fusion 360, OpenCAD, and others. Many of these projects, when drawn for the CNC, are essentially 3D objects made up of multiple flat pieces. You can then take those pieces of the 3D object, break them apart, lay them flat, create toolpaths, cut it out on the CNC or the laser cutter, and then assemble it. The image on the left shows what the flattened design looks like, and the dotted lines in the image on the right show the toolpaths that will be cut on the CNC. Once assembled, you may even create vector graphics to print on a plotter or cut out on the vinyl cutter to decorate your project, in this case the bar top arcade. One more example, using the sign outside of Makersmiths in Purcellville. 2D drawings can be made part of your project and then imported into 3D vector drawing programs and extruded so that you can see what your project will actually look like when it's assembled. The image on the left is the original project drawing done in Inkscape that was done to scale. On the right is the view of that design after a bit of work in Fusion 360. So now we're going to show you some examples of drawing in Inkscape and Fusion 360, albeit some really basic examples. I use Inkscape because it's free for anyone, and I use Fusion 360 because it's free for hobbyists. You can use other vector drawing programs which operate often in very similar ways. Here are some quick examples of drawing in both programs. So this is just a really basic example of how to take some objects and manipulate them with other objects in Inkscape. First draw a rectangle, and then we've drawn a little circle, and we're going to attach those circles to the corners of my original square. So then you can use path functions like difference and cut out the corner of your rectangle, or do path and union to join them together. Then what we're going to do is we're actually going to expand the bottom of our rectangle. We're going to click that node in the middle, we're going to drag it out, and then we're going to turn it into a curve. Now the idea here to show you is the fact that rather than editing pixels, drawing separate lines, and trying to draw like you would with a pencil, vector imaging actually works really nicely in terms of editing the objects you've already drawn. In addition, you can take text and you can move it around on the inside of your object, something that would be very difficult to do if you are working in a raster-based drawing program. In this example, we're taking a picture that's already been drawn as a vector image and manipulating the nodes to change the image. So in this case, making the horse a little bit fatter, adjusting the look of where the leg is on the horse, and then also, just for a bit of fun, giving him a giant tail at the end. So again, just clicking nodes and then changing, in some cases, the curve that's applied to each one of those nodes to adjust the look of the picture. So now we have another example in Fusion 360, and what we can do is we can actually draw our objects with a little bit more precision than we do in Inkscape, because as you can see, whenever we create a circle or create a rectangle, it actually gives you the option to put exact dimensions in when you're doing so. So this is basically just a simple circle with two rectangles in the middle, but then what we're going to do is we're going to extrude it. So you could use that two-dimensional picture in a CNC or laser project, but what this does is it actually gives you a three-dimensional look to see what your project's actually going to look like. You could also 3D print this if you wanted to. Because it's a vector, what we can also then do is we can edit our sketch afterwards, and we can take out one of the rectangles, and then we can actually put a fillet or a curve on one of the lines of the others. Then when we hit OK, it actually takes all that and keeps our extrusion and gives us a new shape. Now we'll talk a little bit about the overall design process that you would use to do a CNC project. In my opinion, for most CNC projects, you're only spending about 10% of your time actually setting up the machine and hitting go. That's the easy part at the end of the day. Most of your time is actually going to be spent doing your drawing, whether that's in Inkscape, Fusion, etc. And then about 30% of your time is going to be setting up the tool paths, which we've shown you a little bit in VCarve today, but can also be done in Fusion 360. Shown a different way, for most projects, about 60% of your time is going to be spent in computer-aided design tools, like Inkscape, Fusion 360, etc., actually drawing your picture. 30% of your time is going to be spent creating the tool paths or doing computer-aided manufacturing. And then only about 10% of your time is going to be set up in fixturing, which involves securing your material down to the CNC work surface and actually using the controller software to run the G-code that came out of your other software programs. So to show a quick workflow for the horse sign that you saw earlier in the presentation, that started with a picture taken from Google Images. Then using Inkscape, I traced that picture, adjusted, made it look right, added the number 40, then imported that picture into VCarve and created the toolpath that would then cut out where I wanted it to, all of the wood on that project. And then about 10% of the time was actually just setting it up and cutting that out on the big red CNC. So here's a slightly more complex project made out of two different woods and glued up together. So first of all, this was actually all drawn in Inkscape in the first place. It didn't need to be done in any three-dimensional drawing program. But in this case, we actually took that initial drawing from Inkscape, brought it into Fusion 360, extruded it so it could actually visualize what it was going to look like in 3 dimensions when it was all done. But we didn't actually need that Fusion file. So I went back to VCarve, imported the Inkscape drawing, and created 4 toolpaths, all using a 1/4-inch end mill. A couple to cut the individual darker wood pieces out, a couple to cut the recesses out where the dark wood would be glued into, and then a couple to actually cut the whole project out and create the bear paw itself. So in this case, 10% of the time spent waiting for the project to cut might have been a little short. There could be a little bit higher percentage there, but in terms of actually setting the material down, hitting go, even less than 10% of the whole project. So here's a slightly more complicated project. Same steps as the previous ones, but instead of drawing in Inkscape to begin with, I drew the whole thing out in 3 dimensions from the beginning in Fusion 360. Now you could draw out multiple parts in Inkscape in 2 dimensions and assemble them later if your brain works that way. Unfortunately, mine doesn't. So instead of drawing in 2 dimensions, I start by drawing in 3 dimensions, but then I export a 2-dimensional drawing of each one of the faces of my project. In other words, the arcade controller top has a drawing, the sides have a drawing, the area where the monitor cutout is has a drawing, etc. And those can all be exported directly from Fusion 360. So then I import all those individual drawings into VCarve, lay them out flat and organize them so that they all fit on a 4x8 sheet of MDF, then create a bunch of toolpaths, the cam part of the process, which tells the machine, hey, I want to cut out these grooves, I want to cut out these holes in the controller top for my buttons and my joysticks, I want to drill these holes in the back for air circulation and these holes in the little section underneath the front bezel for the speaker sound to get out, and then go ahead and export the G-code from VCarve, take that over to the big blue CNC machine, set up my 4x8 sheet of MDF, and cut the entire project out by hitting go once. So lastly, here's some advice based on my experience of which CAD and CAM software you can start with. So when would you use Inkscape for your CAD or your design work? Well, first of all, Inkscape is made for drawing vectors, so it's good from the beginning. Learning to draw in Inkscape can also help you with projects on the laser cutter and the vinyl cutter as well. It's really good for non-geometric, loose-tolerant art designs, and I'll talk about what that means in difference when we talk about Fusion 360. It is really limited to 2D drawing, so it's good for the CNC laser and vinyl cutting, but not necessarily as good for 3D printing. Inkscape is free. There are lots of online tutorials out there to show you how to use it, but also some of the advanced functionality and the little special path tools and other things that are built into it. The scalable vector graphic format from Inkscape can be imported into other programs like VCarve, Fusion 360, Corel Draw, Sure Cuts a lot for the vinyl cutter, and many other CAM programs. And if you're looking for a good resource, I highly recommend looking up Logos by Nick on YouTube for learning how to do various types of drawing in Inkscape. So why would you do your design work in Fusion 360 rather than Inkscape? Well, Fusion 360 is really the best for projects where you need to see your project in 3 dimensions, where you need to set up multiple parts that are going to end up getting attached to each other somehow, or where you need everything cut to very, very exact specifications. And the Fusion 360 skills are good for CNC projects and 3D printing, but they're less relevant for things like laser cutting and vinyl cutting. It's got a high learning curve, but it's also very powerful. You can import other vector images that you might draw in Inkscape or other programs into Fusion 360. And one place where you might use Inkscape instead of Fusion but combine them is for something like the horse image that was used earlier. That would be very hard to draw in Fusion 360, but very easy in Inkscape. So you might do it in Inkscape first and then import into Fusion 360. You can actually do your computer-aided design and computer-aided manufacturing within one program in Fusion 360. There are also lots of alternatives to Fusion 360, including entirely text-based programmatic 3D drawing. It's very handy for drawing and previewing woodworking projects. Fusion 360 is free for hobbyists with some minor restrictions to it. And if you're looking for a good source of video content and tutorials on YouTube, highly recommend Lars Christensen videos and his entire channel for learning to draw in Fusion 360. So when are you likely to use VCarve in your projects? As a Makersmiths member, you're likely to use it during the CAM part of your project, in other words, when you're setting up your toolpaths. There's a computer at each space that is VCarve installed so you can export your G-code with the correct parameters for running your code on either Big Red or Big Blue. In terms of using VCarve for your CAD work, your design work, it is quite limited compared to Inkscape and Fusion 360. If your design is very simple with basic geometric shapes and text, then you can certainly do your design work in VCarve, but anything more complex, and it makes sense to learn one of the other programs first. There are also some good tools built into VCarve for nesting multiple parts to use the least material, and those functions are not in those other programs. And Vectric, the company that makes VCarve, does post a lot of skill and project tutorial videos on their YouTube channel that are worth checking out. So to wrap up this Makersmiths video on CNC, I highly recommend you go onto YouTube and watch some videos about toolpaths, end mills, and feeds and speeds. You could probably also find a project-specific video for whatever project you're planning to do, because somebody out there has probably done it and has made a how-do-I guide on YouTube already. You can also go to wiki.makersmiths.org, check out the Tools, Materials, and Training folder, and then go into the CNC Machines folder for additional content. And last but not least, make sure you join our Slack channel, #CNC, for questions, advice, and to show off your project to other Makersmiths members.